Assalamualikum OyaRahmatullahe OyaBarakatuhu. Welcome to my virtual classroom, MKA CLASSROOM. Now let's start today's video tutorial. Today we will start share valuation model. The valuation model used to estimate the intrinsic value of a share is the present value model. The intrinsic value of a share is the present value of all future amounts to be received in respect of the ownership of the share computed at an appropriate discount rate. Model. The constant growth model has assumptions that model the dividend in this model the dividend growth at a constant rate. That is the assumption, but that assumptions actually is not realistic, in the practical situation. That's why they are alternatively use multiple growth model or varying growth model. The Gordon's share valuation model or constant growth model there has an assumption that is the dividend will grow at a constant rate, but in the realistic that assumptions are not working because the growth in dividends may not be at a constant rate, it may be a varying rate because the company's financial positions may vary year to year. That's why dividends may provide at a varying rate. A typical situation for many companies may be that a period of extraordinary growth, it may be either good or bad, will prevail for a certain number of years, after which growth will change to a level at which it is expected to continue indefinitely. This situation can be represented by multiple growth model, or you can call it two-stage growth model. Two-stage growth model, multiple growth model, or you can call it the two-stage growth model, because in this model there has a two stages, stage 1 and stage 2. This has the two stages. Stage 1 comes from the Gordon's model or constant growth model, and stage 2 it comes from the infinity period. After that the rate is varying rate. That's why first stage we may call it the V1 and second stage V2. It should be continue for period n and it should be continue for period n plus 1 to infinity. to infinity. So these actually are our two-stage growth model, and our valuation model is not equal to valuation 1 plus valuation 2. Now at first we will try to see what does mean V1. After that we will see V2. The interesting value of the share is then the sum of present value up to dividends follows. The follow from period 1 to n. 1 to n. That's we call valuation 1 or V1. And secondly, the follow from period n plus 1 to infinity. One to infinity. That is referred to as V2. Referred to as V2. And combinations these two our valuation model. Now we will see V1. The growth rates during the first phase of extraordinary growth is likely to be variable from year to year. Hence, the expected dividend for each year during the first phase may be forecasted individually. The multiple year holding period valuation model may be used for these first phases, using the dividend forecast developed for each of the years in the first phase. So here we said constant growth rate. Actually that should be multiple growth rate. Multiple growth rate that should be continue for 1 to n year, and it should be n plus 1 to infinity. So here should be the multiple year period growth model, and here should be the constant growth model. So these two models combinations can create this multiple growth model. Okay, now we will see our formula for valuation 1, where dividends can be go through for several years at a different rates, different dividend. D1 divided by 1 plus k power 1 plus D2 1 plus k power 2, and etc. It should be continue to n. It should be continue to n. That means 1 to n. That means at a fixed number of periods that should be continue for n. That means dn divided by 1 plus k power n. That is the valuation of dividend. That is the first phase. Now we will see the second phase. Now the second phase present value is denoted as V2 or valuation 2 and would be based on constant growth model, because the dividend growth is assumed to be constant during the second phase. The position of investor at time n, after which the second phase commences, can be viewed as a point in time when he is forecasting a stream of dividend periods from n1, n2 and n3 and so on, which will grow at a constant rate, that is g. The second phase dividend can be used in this way. Dividend growth is the constant growth rate model. Here should be power 1 2 3 4 5, here should be power 1 2 3 4 5, etc etc etc. It should be continue to so 1 to infinity. The present value of second phase stream of dividends from period n plus 1 to infinity can be calculated in the Gordon's model. Gordon's model dn into 1 plus z k minus g. That's the Gordon's model. Here extra include 1 plus k power n. It may be noted that this value is present value at time n of all future expected dividends from time period n plus 1 to infinity. When this value has to be viewed at time 0, it must be discounted to provide the present value at time 0, time for the second phase dividend stream. When so discounted, the present value of second phase dividend stream would viewed as time 0. That's why divided by 1 plus k power n, that means total value converted to the present value. Total value converted to the present value. That means Gordon's model or constant growth model turned into the present value. So now we will see these are our Gordon's model. Dn into 1 plus z divided by k minus g were constant growth model. Constant growth model. In previously we have learned multiple year growth model and constant growth model. So in previous classes we have learned the several ideas. So these are the constant growth model. And for calculating our multiple growth model, we have to convert this constant growth model into the present value. That's why we have to divide it by 1 plus required rate of return power n. So these are the present value of this constant growth model, that is V2. And previously we have discussed V1, which comes from the multiple year period model. Multiple year period models. First part, multiple year models has the two part. One is dividend part, another is selling price part. So we take only the dividend portions, that is dividend portions. We take only the dividend portion divided by 1 plus k power t or n, summation. That means it should be continue d1 d2 d3 d4 and 1 plus k 1 2 3 4 power. It should be continue till to n. So and now our total total valuation model should be D naught equal to. So our valuation model is summation dt divided by 1 plus k power t plus this portion is multiple year valuation model, multiple year, and this portion should be constant growth model. So these two models can be create our multiple model, plus n dn into 1 plus z divided by k minus z into 1 plus k power n. This is our total multiple model. Summations create a multiple model. Now we will see an examples. This is a two-stage growth model. A company paid a dividend of 1.75 per share during the current year. So at first we have to write down our problem. It says that current dividend, that means D naught 1.75. A company paid a dividend 1.75 for per share during the current year. That means it should be D naught. It is expected to pay a dividend 2 per share during the next year. During the next year, it should pay dividend 2. Investors forecast a dividend of 3 and 3.5 share respectively during the 2 subsequent year. That means it should be D2 3 and D3 equal to 3.5 dividend they are expected to receive. After that, it is expected that annual dividends will grow at 10% per year into an indefinite future. After that, after 3 years, that should be grow at 10% for indefinite future. If the investor's required rate of return is 20%, then what should be its intrinsic value? Here say its required rate of return is 20%, then what will be its intrinsic value of these shares? Now here has the information we have to calculate. Here say D naught 1.75, next year's dividend 2, after 2 subsequent years, that means D2 and D3 should be 3 and 3.5. After 3 years, the dividend will grow at a constant growth rate for the indefinite period, that is growth rate is 10, and that investors required rate of return is 20%. Then what will happen to our model? So at first we have to calculate V1, then V2. So it is very easy to calculate for us. So first one we have to calculate V1, that means dividend portions. So from our problem we see that next year dividend should be expected to, after that 3 and 3.5. So from our valuations model V1, then we can receive the value of dividend, present value of dividend. So by the calculating this problem with the help of our calculator, value E should be 5.78. So if we calculate, so here has said required rate of return is 20%, that means 0.20 or 0.2, and growth rate 10%, that means 0.10 or 0.1. if we express it as our decimal period. Now we have to see the value of V2, that means the portion of constant growth model, present value of this constant growth model. We will see now this from our data. Valuation 2 for present value of constant growth model, 3.5 into 1 plus G, that means there has the DN, that means last dividend, that means year 3's dividend 3.5, and it will grow for the next year 1.Z, 1 plus G or 1 plus 0.10 divided by required rate of return 20%, that means 0.20 or 0.2 minus G 0.1 into 1 plus 0.2, that means 1 plus K power N, that is our formula, then 1 plus 0.2 power 3, and you may call y power 3 because at the end of year 3 our dividend was 3.5. so we are calculating this value at the end of year 3's present value, so it should be, then there is 0, it should be converted to into year 0. By the calculating this problem by our calculator, then we will see 22.28 our V2's value. So we will see our valuation model V1 plus V2. So V1 we have found 5.78 plus V2 we have found 22.28. then our intrinsic value of this problem is 28.06. so this investor is advised to purchase this share if this share's market price is below below this intrinsic value, that is 28.06. if the market price of this share is below of 28.06, then the investor should purchase this share. This all about today. Stay home, stay safe. Assalamualaikum warahmatullahi wabarakatuhu.